Hi everyone, I'm Ioana, and I'm going to talk to you today about unlocking speed and sanity, parallel Android development, faster features, and stress-free testing. Hopefully something here resonates with you or makes you interested in it. I've been with Ford ever since I was a graduate, so that was a few years ago, and surprise, surprise, I'm an Android developer there. So today I want to take you on an adventure, and you will see that in my slides. But first of all, I want to take you through a little story that I have prepared for you, so I hope you'll enjoy it. So, some time ago, the idea of Ford Telematics app was born. Have you heard about it?
Yes.
Thank you.
I hope so.
A team of 15 individuals were going to revolutionize the way fleet drivers manage their day-to-day work. So their mission was to bring this app to life, as you'd expect. But they encountered a critical point, and I'm sure most of you here have the same experiences. How are they going to build the app right away whilst the backend services and APIs were built in parallel, right? So we probably all of us experience backend and having backend services having to be built and then us waiting for them to finish off. So what if they could simulate the backend's behavior, allowing them to build the front-end features in parallel? What about that? The solution? Well, that's how we came up with the mock server idea. And that was the story. But the presentation is not over yet.
That's the beginning.
So let's go through the agenda. So today we're going to go through parallel Android development with the mock server. How do we enable faster features with mock server's help? How can we achieve stress-free testing? And finally, some outcomes, lessons, and what's next for us. So the first topic is parallel Android development with the mock server, and that's the first stop of our journey, of our adventure. So mock server strategy, I've been talking about it for a few slides now, but let's see what it is. So of course, we all know what a mock server is, but why did we build it? So we build it so that we can accurately simulate the behavior of the real backend services. So how does it do this? It does this by intercepting the API requests and providing control responses. So you might think, okay, so what are the benefits? Well, first of all, it allows the front-end team, so it's us, to develop while the back-end team develop independently. So without us needing to have the access to the real endpoint. So why do we do it? Well, it provides flexible responses, enables robust testing and reliable testing, and we're going to go through all of that in a bit. So what does it require? Well, for this to work effectively, as you expect, it requires close collaboration and open communication between front-end and back-end teams. Otherwise, it's not going to be possible, right? We need to establish the contracts. We need beforehand, of course. We're going to go through that one by one. So what do we require from the mock server itself? Well, we want something that is fast set up. We want something that we can start and stop and reset easily. We don't want to make our lives harder, right? We want to improve it. We want something that is realistic. So the data, we want it to be as close as possible to the actual backend. So we don't, build something and then when the backend services goes live, we see that it's totally wrong. And we want something that enables us to simulate the errors easily, right? All the happy paths, error, unhappy paths, edge cases, we wanted to be able to simulate it with a few clicks. And of course, performance, right? So backend services usually take a little while to load. So this is basically instant. It could be if you want it. Of course, you can add latency to see how your app behaves in the mock server, but if you want a very quick response as you build it or as you test it, then it is instant. So let's have a look at the tech tools and the tech stack and tools. So we use Kotlin. Well, it's easy, right? We're used to Kotlin from our day-to-day work. So using that in our mock server code base makes it easy. We use Ktor, which is the Kotlin framework for building asynchronous servers and web APIs. We use Gradle, I bet that's not a surprise, for build automation and dependency management. And we use static JSONs to provide the responses. So how does it actually work? Well, developers can easily select responses from a scenario. Response scenarios, right? So the server basically delivers the appropriate response based on what you choose. So if you choose success, it will deliver the JSON that is according to that. Also, we use it for WebSocket simulation. So we use Ktor's WebSocket support. The server sends a sequence of mock frames and handles the client messages and allows interactive messages pushing from the UI for dynamic testing. We're going to go through that later, so I'm not going to go into more details right now. We can have dynamic data. So most of our mock server uses static data, but you can have dynamic if you choose so. For example, like dates or things like that to simulate the actual backend response more realistically. And of course, modular architecture, we use it in our code base, in our apps. We use it in mock server code base as well. It's easy to add endpoints, to remove endpoints as we need. So it makes our life easier, really. So, what does it use? Well, it uses scenario management. So we use Kotlin enums to represent the different states or scenarios for each API. So success or empty or error, or if you have a different error, like a special case error or something like that, we have an enum for each of those. Data source, as I said, we have JSONs, static JSONs that simplifies management and updates. We update them based on the backend contracts, so it's easy. I'm going to go through that as well. State management basically supports session-based states, so we can allow multiple simulations. So, for example, if we want to see how we have these 3 endpoints that are kind of in chain, we can change each and every one of them. It doesn't have to be one endpoint at a time. And of course, it runs locally, so we can have it on all our machines and not interfere with each other. So WebSockets, I did say I'm going to go back to that. So as you can see right there in the screenshot, that is a screenshot from our mock server UI. As you can see, we have their own connection. It is success in the screenshot, but of course you can have error or other scenarios. Also, you can request a new token. You can disconnect the WebSocket, and over there where I pasted hello, you can basically paste the whatever response you want. So we use Ktor WebSockets to simulate the real-time communication that is required by the features such as a live map, updates, or whatever you may want to use WebSockets for. The server defines the WebSocket endpoints and sends sequences of mock data, as I mentioned before, to the connected client. It manages the sessions, handling initial data, listening for client messages and responses as needed. And of course, the logic is modularized, so it's easy to create and test different scenarios, such as success streams, errors, or disconnections from the WebSockets or anything that you may need. And that concludes our first stop. Let's go to the second one. How do we enable faster features with mock server's help? So, as I said before, we have multiple scenarios that we support. So we support happy paths, we support unhappy paths, like different kinds of errors or pagination. That's not a happy path, but pagination, empty states, and of course testing. So it is the QA's companion. QAs can use it very easily to test different scenarios very quickly, and also integration testing helper, as we will see later. So how does it work on our day-to-day work? Well, when we decide that we want to have a feature, we plan it. We t-shirt sizing, we have these meetings that probably all of you do. We look at what the feature needs. We discuss any edge cases, any more investigations that we need. If that's the case, we go on, have spikes, and come back with our findings. And of course, the PMs also plan the backend work, and that's the first point there. API contract agreement, so I cannot stress that enough. We need to have close collaboration with the backend team. So usually the front-end backend team and QAs collaborate, define the endpoints, agree on the contracts, and the backend team tells us what they can provide us with. We tell them what we need from them, and we come to an agreement. And of course, that agreement, we have like a shared space where the endpoints are going to be presented by the backend team. So something like Swagger, we see over there. Snippets. They're nice enough to paste snippets of what a success response would look like, an error response, and so on. So what we do is, we take those snippets, we go back to the team, we create the story. That means updating the mock server from our end. We take the snippets and we use those to actually provide the mock server repository with the JSONs. Of course, we don't just copy and paste. We try to think about the edge cases, about different scenarios, and we modify those accordingly. Those snippets that we just copied, for example, success, maybe we want a super long address for an address field of empty or so on. And then, of course, that's when actual parallel development begins. So as you can see over there, we kind of got to where it says front-end and back-end. We implement contract on mock server. Back-end team can nicely go on and develop the actual real endpoint. And because we have a mock endpoint on our mock server, we can start developing the front-end work in parallel. So that's nice. But of course, that's not the end. So we shouldn't just stop at testing. Okay, it works with the mock server. The backend has finished. Okay, let's ship it. We need to test it, that it actually works as we expect with the real endpoint as well. So how do we add this new endpoint to the mock server? Well, we have a few steps. So we define the feature. What does that mean? Well, I will skip talking about enums. So that's what we call a feature. It's like an enum class where in a particular package, so let's say features, and we create basically there an enum class with the responses that we expect. We have add mock data. So basically, as I said before, we copy the snippets, we adjust them, and we place them in a directory of our choice, for example, resources and whatever the JSONs we want. We'll see about that in a little bit. Implement the handler. So of course, now we have the feature, we have the JSON, we need a way for them to communicate. So that's where the handler comes in. That is basically a function that directs those enums to the particular JSONs. And then we need to register the route. So in Ktor routing, we need to add a new route so that when that endpoint comes in, be like, oh, what's that? Oh, I know this is using this handler that points to this JSON because it's this enum thing, success or whatever. And last but not least, of course, in order to be able to use it, we need to update the mock service UI. Otherwise, it's going to be pretty pointless for us. So let's go through an example, right? So remember those steps there, because I'm going to go through each and every one of them. So define the feature. As you can see here, we have an enum class. In this example, we have, let's imagine we have an app with a list of vehicles, and we can have success, all of them load, empty, we have no vehicles, or error, the endpoint didn't load for a particular reason. So that's why enum we created. We have the three error cases, and that's it. Of course, you'll see here a few other fields. So we use this header here. We use for switching mock responses, and we have this state here, which basically determines which enum to use for a given session, so that it allows different responses per session. So this is the feature and enum that I was keep mentioning about. Of course, add is the adding the JSONs. As you can see, we have a JSON for error, one for empty, one for success with 2 vehicles. There's not a lot I can say about that. It's pretty straightforward. Going on, implementing the handler. So as I said, we need a connection between the two. As you can see over there, we have the features that are success, empty, error. We have the JSONs, and then we connect them, and then we say, when is success? Okay, give me this JSON. When is empty? Give me that empty JSON, and so on. So basically, the main function is called return vehicle list, and that checks the current state and returns the corresponding JSON based on the HTTP status. And then we have a helper function over there, JSON, that you can see that basically sends the contents of a JSON as a HTTP response. And then we go on to register the feature in mock server. So how do we do that? Well, we have this basically, this is like a default state. So whenever we load the mock server, we will have this vehicle list feature as success. We have a name for that endpoint. And basically what this does is adds the features to mock server's list so it can be managed or switched by having a drop-down we will see in a little bit. Also add a route to indicate our routing. So as I said, when the mock server sees this endpoint, you will know to call the return vehicles list function, which is the handler we've been talking about over here. Okay, and now we will have a video of these endpoints that we talked about. So as you can see, this is the actual screen video of our endpoints. We can see that this is the vehicles one that we've been talking about, and then we can click on the vehicles endpoints. We will see the name we gave it, and then we can choose between the responses over there. And to make it nicer, we added a link that will take us to the documentation. Of course, this is something of internet, but if you have a Swagger or whatever, you can point towards that. So it'll be easy for you to see the actual documentation that you and your team use. All right, so now we have all this implementation. We raised it in a PR, it was merged in the mock server repository. So what do we do next? Okay, so now that we have the PR merged in the repository, of course, we need to do something called jar. We create a jar file, and this slide talks about the jar creation. So we have set up a Gradle shadow jar. Basically, we're using the Gradle shadow plugin over here to create an executable jar. Then the shadow jar over here, this task basically bundles all the dependencies. And of course, over here, we're adding a version so that we can, have different jars so we don't kind of overlap each other. We can have a version jar. And at the bottom, we have a main class property, which is making the jar executable. As we can see here, is using the engine main class. Sorry. And then moving forward to publishing. So now we have this jar. So what do we do with it? So as I said, everything was merged. We go on GitHub, we go to releases, we draft a new release. That's where we attach the jar, and then we publish it. Easy. But we have something else set up. So when we publish that release, we have a job, a CI/CD job that is trigger, and that basically runs the Gradle's task Artifactory publish, which uploads this jar to JFrog Artifactory, and over there, the developers can basically download the latest jar using a custom Gradle command over here. This is just a snippet, but of course, if it has a version, it will include that as well. So it's easy for developers to get the latest mock server version. And over here, the step that I missed is in the app repository. There is a dedicated mock environment configuration, and we're going to talk about that right now. So what about environment? So as you all know, the environment centralizes the app configuration and dependencies like API endpoints, feature flags, and so on. You're probably very familiar with this. We have an interface such as this one. For example, we have API-based URL over here. And of course, you may be familiar with prod and staging environments as well that are using the, well, relevant APIs, however your needs are. But we have a third one here, which is called mock environment. And of course, that API-based URL is going to point to our local host, which is the mock server. And that's how it works. So, back-end, front-end collaboration. I've been talking a little bit about it. So what makes it work? Well, as I said, we have shared API contracts, and that is the key. So you need to define and agree on the API endpoints and structures before the implementation begins. Right there at the beginning, you need to have those meetings, those discussions, and agree on the final contracts, basically. Of course, not everything's pink, things can change, and that's okay as long as you have communication and each one of us updates the other party about the changes, it would work out. And of course, as I mentioned, we extract the JSON snippets directly from the contract. Also, proactive communication channels. So when we start a new feature, we discuss everything in multiple sessions. So we have 3 amigos between front-end, back-end, QAs, where, of course, we design team as well. We discuss designs, but for the purpose of the front-end, back-end communication, we discuss over there the endpoints, what our worries are, how we can make it work, basically. And of course, as we agree, and then if something comes up, we can discuss in future weeks. So basically, that is a weekly meeting. Of course, we have dedicated Slack channels. So whenever we have a new feature, we have a Slack channel for that feature, for the endpoint discussions, where they go. If backend team needs something to be changed, they quickly let us know over there as well as the meetings. So we have clear communication, and we can quickly update the mock server to be in sync. And weekly syncs, of course, we also have other meetings, not just the 3 amigos, or, we have feature-specific meeting where we discuss particularly about that feature and what we need, and making sure that we are on the same page. So the core principle, well, we collaborate early, agree on contracts, and treat mocks as the shared source of truth. So the shared channel that you have, like Swagger, just make sure that is always up to date, that you can rely on it, as well as the mock server for the front end team as well. So now we're going to go through an example. So for example, here, let's have an edge case where vehicle name goes on 2 lines. So basically, in those, what we went through, let's suppose, other than the 2 vehicles, we also had vehicle name. So we have a vehicle name that is probably more common, such as demo vehicle 3, but then maybe someone might want a very long name. So we can have the second vehicle with a very long name. And by doing so, whenever we point to the mock server, we can quickly just check both of these scenarios. We don't need to do anything special. And of course, because of doing that, we can see whether we want it on 2 lines, whether we want it truncated, such as here, or as here. So it's easy, and it's right there. All right, so now we finished step number 2. We're going to step number 3. How can we achieve stress-free testing? And probably that's what makes you all curious. So let's talk a little bit about UI tests and mock server. So as you know, UI and espresso test in Android projects often use mock server to simulate backend responses, so that we can ensure that the tests are reliable and independent of real backend services. So we have a test runner set up. So we have a custom test runner that is set up to initialize the test environment. It often enables the dependency injections, such as healed, and this ensures that all test dependencies are properly injected. So the mock server state management, which is like the mock server feature enum classes that we talked about. We have something similar in our code base for the UI testing, so that it matches those enum classes. And the test implementation, we use these enum help functions to switch easily between the server and different states. So how does the test flow go? So first of all, we need to start the mock server. Then the test enqueues different responses that we write in our tests. The app under test makes different network requests, which are intercepted by the mock server, and you will test based on that. We will see an example shortly. The test verifies the UI behavior, as you all know, based on those mock responses. So enough theory, let's go through an example. So example, and we're back to enum classes. So the first thing we do is for the same example that we had before, vehicle list feature, how do we test that list of vehicles? Well, first of all, we need to create an enum class with again, the three scenarios that we had, success, empty, and error. And then what do we do then? Well, we create a mock server robot. So this class basically configures the mock server to return a specific response. So over here, we have success vehicle list, and then we configure that we're going to return success in the mock server. Empty vehicle list is going to return empty, and so on. Then we're going to create a fragment robot, which you're probably used to. For example, let's say we need to navigate to vehicles. So we will have something called vehicles on our page, and then we perform a click or try again in case of an error. Maybe we have a try again button that we need to click. So basically, these are the test scenarios that we want to encapsulate here. And then we create the verify class. So, for example, verify vehicles over here. So let's say we have a list of vehicles, and as you probably remember from a few slides back, we had one called Mustang. So we just verify that that one exists and is displayed. Then we have different cases for show empty, that no vehicles to show. We probably display that text on the screen so the user knows. Or for an error, again, we probably display some text and a button for the user to know that he didn't succeed. And we have methods to verify all these. Of course, this is an easy scenario. You're probably going to have a lot more than this. And then step 5, we're setting up the DSL. So basically, how do they work? So these functions allow you to chain together the mock server setup, UI actions, and verification in a readable way. It's probably not very readable at the moment, but it will be soon. So this is the setup. So basically, we're connecting the mock server to the fragments and the mock server to the verify block and so on. It's going to make more sense, I promise. So here it does make more sense. So now you can see this is the test, and this is step 6 and the final step of creating these UI tests. So basically, we actually write the test. And as you probably will remember, we had the mock server from the slide before, which is here. And then we are saying success vehicle list, which is setting the response to be success, as we've seen a few slides back. And then on the vehicles, we want to navigate to vehicles. So let's say we have a button that we navigate to vehicles, and then we want to verify that those vehicles are displayed, and that's what show vehicles does. But then we may want to switch back, and then we go back to mock server. We change the response to be error, and let's imagine that it kind of updates automatically, and then verify here is going to show an error. Or over here, the other way around. So we display an error, we navigate to vehicles, we verify, show error, mock server, success, vehicles, try again, verify, show vehicles, succeeds, hopefully, if the test passes. But this is a lot more readable, easy to understand. If you just look at it, you know what it does. And that's how we use the mock server to have stress-free testing. It's easy and fun, and it catches all the possible bugs or defects beforehand. And now that we finished number 3, as I said before, we're gonna go to the last point, and that is outcomes, lessons, and what next. So going through this, we had mock server set up ever since the first launch of our app. And we did see faster iteration. We did see that the number of issues were reduced because it's easy to test all the edge cases, all the errors very quickly. And of course, we have all the test suites that also help with that. Also, back-end and front-end decoupling, we can, as I mentioned, we can work in parallel with communication, of course, don't forget about that. But we can work in parallel and we can agree, and then at the end, when the real back-end services are available, we can just test that everything works as expected. Easier onboarding, of course, if you have new developers joining the team, it'll be easy for them to understand what endpoints you're using, because all of them, it's in the UI that I showed you before, and then they can just see them, play around with them, have a link to the actual documentation that they can read at any time. And demo-friendly builds for PMs and QAs. So QAs, PMs, devs, we can easily see or simulate different behaviors. So, for example, if you want a behavior that you don't really want to test in prod, so like, I don't know, unlocking someone's vehicle, you probably don't want to do that unless it's your vehicle. But you can use mock server for that easily. But as I said, it's not all, roses, or however the saying goes. We do have challenges and we have lessons learned. So, of course, one of the challenges is keeping mocks in sync with the real APIs. So it's easy under stress to kind of do a small change and then forget to maybe communicate it or something like that. So that's why that's why I kind of stress out that communication is needed along the way, and even more than that, we need to be in sync, because it's easy to kind of deviate because of deadlines. Mock data becoming outdated, again, is kind of linked. We need to stay in touch. We need to make sure at any stage that those contracts align. Mock server and the real API, that is. And of course, environmental drift, so differences in data, authentication, business logic can cause small differences between mock server behavior and actual endpoint behavior. We actually have seen it, and it doesn't happen very often, but it does happen. So that's why it's important for you not to rely 100% on the mock server. Right at the end, you need to make sure that you do a bunch of testing, regression testing, using the actual real APIs. So what's next for us? Well, we are thinking about having another environment, basically something called maybe a demo environment, where we can use the mock server responses from the jar file without having to start the mock server. So as I've mentioned before, we need to have the mock server started at the moment in order for our mock environment to work. So what if we could somehow just use the responses from the jar and have a demo environment, which is going to be beneficial for like the sales team, if you want to demo someone that you don't want them to play with the actual APIs, or it's a lot faster as well. Because you don't have to wait for responses or anything like that. So having this is our ongoing work at the moment, and this is something that we are very keen to do in the future. Also, it's very useful for running integration tests in CI at the moment, because we have to have the mock server started. It's a little trickier, so this will make it a lot smoother. So that's what we're investigating at the moment. So what can you take from this talk? Well, parallel development is possible. It just needs a lot of communication between the teams, which is nice. It's nice to be, in sync with each other, right? Mocks are a team asset. So as I said, we need to treat them as a shared source of truth. So we need to make sure that we align. We can test edge cases early, so there should be no reason for us to say, oh, I didn't think about that. Well, with this one, we should have. Invest in tooling and team habits. So, of course, if you don't, if communication is not your strongest suit, you need to invest in that for this to work. As I said numerous times, it is something that would make it work. We need collaboration, communication within the team. So if that's not something that's happening necessarily as frequently, that is something that needs to change with this mock server idea in your teams. Collaborate on contracts first. So that is the starting point of any feature. Collaborate and agree on contracts, and the payoff is real, trust me. Okay, and that's the agenda done. We are going back to parking now. Thank you very much. I hope you enjoyed the talk, and